and I just welcome you all over here. So let's get started with the very first question. A ball is thrown upwards with an initial velocity v0 from the surface of the earth. The motion of the ball is affected by a drag force equal to m gamma v square, where m is the mass of the ball, v is its instantaneous velocity, and gamma is constant. The time taken by the ball to rise to its maximum height. This question has been asked in IIT Mains 2019. So we are just going to solve the question along with the explanation. So what is the basic idea we are going to get from the question is the dragging force experienced by the ball is mv square gamma, where the initial velocity is v0, and our objective is to find the time taken by the ball to its maximum height, to reach to its maximum height. So basically we do know that the basic equation of force F is equals to ma, that is our equation number 1, and F is equals to mv square gamma, that is equation number 2. The equation number 2 is basically given in the question. So on equating 1 and 2, what we will be getting, it's ma is equals to mv square gamma. On cancelling out, a will be equals to v square gamma. Since we have thrown the ball in upward direction and the ball is experiencing the retardation, that's why the a net value will be g plus v square gamma with a negative sign. Now we do know the a can be written as dv upon dt. A can be written as dv upon dt. So on cross multiplying, we will be getting dt is equals to dv upon g plus v square gamma with a negative sign, isn't it? We are going to get that. Now we need to solve this equation. So what we can do, since gamma is constant, we can take gamma as common. So minus dt will be equals to dv. Gamma has been taken as common. It will be g upon gamma plus v square. This g upon gamma can be written as gamma under root g upon gamma. This under root will be a little longer since the total value should be inside the under root, square plus v square plus v square. So this is the equation we will be having, minus dt. Now we are having the formula of integration. The formula of integration is dx x square plus a square is equals to 1 upon a tan inverse x by a. This is the formula we are having. So we need to convert this initial equation into this formula. We need to convert this initial equation into this formula, and then we need to integrate it. So let's go for the integration. Suppose we have thrown the ball at t equals to 0 time and it has reached the maximum height at t time. The initial velocity is v0, that we know very well, and the velocity at the peak will be equals to 0. So if we take gamma as common, then we will be having this value 1 upon gamma integration v0 to 0. It will be dv upon under root g upon gamma whole square plus v square. Now as you can see, this equation is quite in resemblance with the previous equation that we have written over here. So that's why the equation will be equal to, we have compared a with the constant part, that is g and gamma, that is the constant part, and v is the variable. V is basically the variable we will be getting over here. Now, as we can see that integration of dt will be t with a negative sign, 0 to t will be equals to 1 upon gamma, we have already taken as common, into 1 upon a. A means g upon gamma, tan inverse x was your v, x upon a under root g upon gamma. This is the value we will be having. Now let's keep it inside the big brackets, v naught to 0. So when we put 0 in the place of variable, which one is the variable? V is the variable. Okay, when we put 0 over here, all the part will be equals to 0, obviously. So the value will become now, the t minus 0 will be over here on the LHS part, and on the RHS part, if we just elaborate it, we will be having tan inverse. The total will be in negative values because upper limit minus lower limit. When we kept the upper limit, the value will be 0, v will be 0, and the total value will be 0. Now we have kept the lower limit. The lower limit is v naught over here under root g, and it will be gamma. Big brackets close. Okay, so this minus and this minus will get cancelled out, and the final value will become t is equals to 1 upon under root g gamma tan inverse in brackets v naught under root gamma upon under root g. This is the final value we will be having. Thank you.